Hey, what's up, guys? It's t.rex here, and today in this section we are going to look at the last parts of the interview. This will be literally the miscellaneous and more general kind of subjects as far as the paleontology goes, and the research, and how to conduct it properly, and just a portrayal of dinosaurs in the media and all the things alike. However, this is not obviously the last part of the whole thing because there is a bonus section, and I strongly recommend you stick around and stay tuned for the final video, which will be the creature review, which will be done exactly in the same manner as I do my creature reviews, give or take, of course. But this time it will be me and Dr. Thomas Carr doing a creature review of Tyrannosaurus from Jurassic Park franchise. So stay tuned for that, and in the meantime, enjoy the part 4. So let's move on to the next section. This will be the general questions section, which will cover miscellaneous parts that probably have not been covered yet. So, what is your favorite dinosaur-related pet peeve in the media? If there are several, let's discuss them.
Um, in general, like the type of stories covered, or more specifically, images.
I don't know how to narrow it down because there are just so many, aren't they?
Yeah. Well, a couple things. I guess there's been a lot of attention given to the T.rex slashing. You know, the forearm slashing. The T.rex's forearms were used to slash prey. That's been getting a lot of attention. And it's just my concern there is that 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 work isn't yet published, and yet it's getting a lot of mileage. And so my concern is that the public assumes that work has been through peer review, and my understanding is that it hasn't yet. I'm sure it will be submitted for peer review. And so I think in general, there are some stories about dinosaurs, not just T.rex, that might be based on preliminary research that haven't been through peer review yet. And the public might assume, well, okay, this has been through that rigorous process. So I don't mean to pick on that one in particular. It's just recent and timely, and it has been in the media for a couple weeks now. So I think when it comes to stories about dinosaurs, it's important that people pay attention to whether or not the research has actually been published in a peer-reviewed journal or not. And just sort of to cut everyone some slack here, there is often a media presence at scientific conferences. So this research was presented at a GSA meeting, Geological Society of America. And journalists do attend big meetings, and they do report on presentations there. And that's sort of important for, scientific outreach to the public. I think that's an important role that, the media has every right to be there to help share what we're working on with the public at large. But it's important for the public to make the distinction between work that has been through peer review and work that hasn't. That's one, one concern, or it's not necessarily a peeve. It's just a concern that I have.
Sure. Yeah, of course, it doesn't really have to fall into every single definition of peeve. It's just like things that kind of concern or give you like a bit of an yucky, whatever feeling, if you know what I'm saying.
Yes.
So, any more, like for example, anything that you have seen in the computer games that kind of was like forcing you to literally go facepalm and wish you would unsee it? I'm pretty sure there has been some, or have you not been up to date with computer games very much?
Not very much, but of course I have seen the various versions of the digital models that Saurian has produced, and of course above and beyond games, dinosaurs in movies like Jurassic Park, Jurassic World, that sort of thing. I guess my pet peeve in general with depictions of dinosaurs, in particular T-Rex, is they aren't often very accurate. And I do appreciate, it looks like the group at Saurian is making every effort to produce accurate models, including their T-Rex models. They even have a growth series, which is quite
let's
cool.
open up the series of ontogeny. It's an old image, though, just mind you. So basically, this was produced a while ago, before obviously the. I mean, here's the thing. I mean, there's been a bit of a conflict going on about the accuracy of these models specifically, because even before Bell et al. Got published, there has already been an acknowledgement of obviously scaly tyrannosaurids rather than feathered or partially feathered, and also complete lack of evidence of feathers also, and using other species or just groups which show them to basically fill in these gaps and to basically feather in the gaps. Like, there's just a whole lot of craziness going on with that. And one of the major points that I wanted to emphasize was that even the frequently referred paper, I believe it's Xu et al. 2012, which is the only paper up to date that discusses the publication of Eutyrannus specimens. And even they acknowledged the diversity between the late Cretaceous period Tyrannosaurids and the earlier period Proceratosaurids, although they have not, if I remember, yet referred to them as Proceratosaurida, but I will have to check that. But generally speaking, they already acknowledged that diversity, and yet that was conveniently, just scored out, and let's not look at this, because feathers! And then everybody started dressing them up in feathers, and you know the rest of the story, I guess. You're up to date with that.
Yeah. Well, my view on all of that is this, that if I was their consultant, like say the consultant for Saurian, Jurassic World, or any other major effort to reconstruct dinosaurs, T-Rex, I would, my advice would be is, there's no feathers. The evidence shows small scales, so give them small scales and big flat scales on their head. So follow Carr et al. 2017 and Bell et al. 2017. That's our baseline of knowledge for integument, so follow that. And I just for the record, I have not been consultant for Saurian or Jurassic World. They haven't come to me, but if they did, that's what I would advise.
Good points, indeed. The good news is, though, to this story, like I've given you the bad early version of the news, while what was causing the problems and lots of flame wars over the internet between the so-called, pro-feather camp and the pro-scale camp. And they have actually given, I'm not in detail familiar, but they have given some news that they're planning to update their models. Scales and naked skin. This is one of the pet peeves I actually wanted to mention and to ask you what you think about that, because it seems a lot of people confuse the idea of scales being not the naked skin. It's also a cover of some sort. It's an integument, it's a structure, which is not the bare skin.
Right. Yes, I mean, like I said, if I were a consultant on this, I would have them make, scaly skin and make sure that the scales are small, at least on the body. I don't see any necessity for a naked skin morphology. We just don't have evidence for that. But I think it makes sense to show what we have evidence for, and that's a scaly integument from, like I said, from the tip of the nose to the tip of the tail. And then, they're making their decisions for whatever reason.
Well, I mean, let's at least give them, I don't want it to make it look like I'm bashing anybody here. I'm just giving, also, we're giving our honest opinion based on what we're seeing right now and what we have already got in terms of the information that has been presented. And the pros, I think, in my opinion, and correct me if I'm wrong, is that they've given quite a good attention to the ontogeny sort of aspect of the species. So that's a good thing. And speaking of, since you are currently working on this aspect, this is obviously a good chance to look at and maybe give a little kind of side note to this, whether or not you see a pattern and whether it's consistent or not in general terms.
Well, let me just, considering skin, let me just put it this way. Way back when I was, when my interest in dinosaurs had returned, I reached out to Dr. Dale Russell, who was then at the Canadian Museum of Nature. And his advice to me in terms of learning about dinosaurs, he said the most important thing that I can do is pay attention to scientific literature. Because, at the end of the day, that's where all the information comes from, and it's been vetted through the peer review process. Doesn't mean that everything that goes through that process is gold, but at least it's been vetted. And that's the advice that I would give to, say, the folks at Saurian and Jurassic World and whoever else that are taking on dinosaurs. And that is, give the scientific literature its due, let it be your guide. And you may like the look of dinosaurs, say, with feathers, but if the dinosaur in question has no evidence for feathers, then there's no justification to put feathers there. And in that way, you keep yourself aligned with the science and not with fantasy. And people will respect that.
I think it's also important. Let's kind of, again, coming from me, it may sound like bashing, but let's just kind of take this into very important, context, I guess, that what I'm about to say is not
Sure.
bashing, but it's more so something to worth noting in case maybe the creators and the developers have not, you never know. Sometimes you just miss certain things out and it just then strikes you like, oh my God, how could I? One of those situations. So I'm hoping this is one of those situations, but in their website, obviously their flag, the front page says the most accurate dinosaur simulator game ever been made. And yet, in their credits section where they introduce their team, I haven't seen the team of the paleontologists that they have consulted and all of the list of the citations that they have used to support their, statements, I guess, or whatever they're doing, their choices. So it would have been nice to see that sort of thing, to show exactly where they're getting things from, so that anybody, any person, at least with a half a brain, could go onto the website, look in the credits section, and test all of their hypotheses and see whether or not they're consistent. And basically accept the compliments and learn from criticism. Make sense?
Yeah, that makes sense. I don't know who the consultants are for Saurian or for that matter, Jurassic World. I know that Jack Horner is involved with Jurassic Park and the Jurassic World film, so I assume that he's consultant on the one that's upcoming. But yeah, that's helpful information to know. I guess what I can say is that the Saurian dinosaurs in particular, it's clear that a lot of work has gone into them. They're definitely stand head and shoulders above others that I've seen, and I think it's a laudable effort that they've taken on to try and get the dinosaurs right. I actually, as you know, I dig in the Hell Creek, and it's nice to see those animals get their day and to see so much effort being put into, getting them right.
I think one of the pros that I can also add is that they've made a lot of good and well-deserved, I guess, as in worthy of the compliments effort into detailing out the period that they're representing overall. Like, as a general feel, graphics can be fixed, let's just be honest about that. That's just technical part. That's not what we care about. We care about the period, the animals, the portrayal, the looks, the behavior. Speaking of behavior, we will touch up a little bit on that in a moment, but yeah, that's what we care about. So my going back to the point is that we have obviously pointed out the criticism. So now, to point out the pros, I think the main pro, if you agree, is that they capture the period quite well of the atmosphere. And this is something that maybe, if worked on in more detail, they could really expand even further. And if it gets popular, they could maybe, try to maybe attempt to capture other periods as well from other places. Something to look forward to.
Yeah, I agree, and I wish them continued success in their refinements. It's quite a lot of work they've done. It's clear.
Knowing that they are still doing work is also nice, because, once you stop something and then you're like, yeah, we are the top, and that's it, that's where it starts going wrong, I think. So the fact that they are updating and they're constantly evolving, so that's a good thing to know. So, you know what I'm saying, like, we give the criticism, like the honey and the hatchet, basically, principle here.
Yeah.
So we've given them the hatchet and we've given them the honey. Now, in terms of, before we get to the bonus content, I wanted to also say, what do you think about the behavioral and social structure, and whether or not there is something we could elaborate on, or is it purely an open-ended question as far as the dinosaurs and, well, tyrannosaurids in general are concerned?
I think, obviously, behavior we don't have. There's only exceptional conditions where where the fossil record does capture what looks like behavior, so the fighting dinosaurs from Mongolia. My basic approach to all extinct archosaurs is the extant phylogenetic bracket. So take a look at what crocodilians do, take a look at what birds do, and whatever is shared, it's reasonable to assume that dinosaurs also did that too. And so we can assume that, dinosaurs ate. We know that crocodiles eat and birds eat, so that's an ancestral feature, so dinosaurs would have eaten too. But obviously people want to know more specific things than that. I do think that the EPB, as I've just described it, is the best way of establishing the null hypothesis, sort of just the baseline. It doesn't mean it's the truth. It's just based on living archosaurs, what should we expect? And then beyond that comes in evidence from functional morphology, ecology, specifics of anatomy that all have bearing on a specific question. So for example, tyrannosaurs, they're obviously carnivorous, and I think obviously predatory, and so we can infer behaviors like that.
There's been some bite marks, I believe, or something of the sort left on some of the Tyrannosaurus specimens that show bite marks from other fellow Tyrannosaurus, so kind of indicating that they could be frequently bickering, even if even if it was not exactly something that's not part of the social structure, it could well be a common thing to do, which is fine with many animals, it seems to me. So do you think this is something worth looking into as well?
Oh yeah, tooth mark bone has direct bearing on this as well. For example, I've seen, I'm convinced tyrannosaurids were cannibalistic. I've seen obvious tyrannosaurid tooth marks on tyrannosaurid bones. So where the tooth has scraped and left the marks of its denticles, sort of across the surface that's been bitten. I think that tyrannosaurids, did eat other tyrannosaurs when a carcass was available. I don't think, there was any hesitation there, but you have to have the evidence. If I didn't see that particular tooth mark, then I wouldn't even venture over there toward that hypothesis. But all these statements have to be backed up by either the EPB or material evidence, and which can come in the form of tooth mark bone, tooth shape, functional morphology, finite element analysis modeling, you name it. There just has to be some defensible rationale for making that knowledge claim.
There is interesting point that you've made about the extent phylogenetic bracketing analysis. If there's no physical evidence available to support, at least, then if you even just rely alone on that, the crocodilians and even quite a lot of species of birds have shown this type of so quote-unquote cannibalistic, and in some cases directly cannibalistic behavior. Because I don't know whether it's true or not, but I've recently watched a program on a crocodile, and once the female and the couple has mated and they produced an offspring, the neighbor males, and even that same male who basically mated with this female, they would then start trying to pick out her hatchlings, and she'll have to literally drag them around to avoid them just so that they don't get eaten. How
Yes.
ridiculous is that? You just basically produced an offspring and then you're just in a rush to eat it. That's retarded.
That's natural selection for you. Well, the important lesson there is that natural selection doesn't optimize, right? Natural selection does not produce perfect organisms. That just doesn't happen. And so we should expect to see these things. And yes, I agree, as you've described it, the general approach of the EPB can help us fill in or can help provide expectations for things that don't preserve. At least, yeah. The important part is that we have a constraint on our inferences, or what we, an inference being what we think, say, a behavior might be like. And that's the first place that my mind goes to when questions of behavior come up for Tyrannosaurus. I'll immediately think, well, what's happening in birds in general and what's happening in crocs in general? What's the ancestral condition that we should expect in Tyrannosaurs? And should Tyrannosaurs be any different from that given how big they are and so on? But it's a very important guide to navigating these questions and eliminating the nonsense from what's defensible.
Is it basically fair to say that phylogenetic bracketing generally as a method can predict similarities within the groups, but should a diversity occur, we cannot use phylogenetic bracketing to predict a diversity. We have to have evidence to predict diversity. Or how does that work? Because frequently people seem to misuse and misunderstand the term of how bracketing should be applied, and they use it to trump the already existing evidence, but we kind of, from my experience and understanding, that's not how it works. So could you please elaborate on that issue for myself and for the viewers as well? Thank you.
Sure. The goal of the EPB is just to set a baseline expectation for the extinct animal. So the simplest way I can put it is that whatever behaviors are shared between crocodilians, and birds, those shared behaviors, they inherited from their common ancestor. Therefore, all the extinct descendants of that ancestor will have or should have that behavior or those behaviors as well. But our reference point is shared behaviors between crocs and birds. They set the baseline. Now, say we are thinking about a behavior where the form of the dinosaur completely contradicts it. Then we have to have an alternate explanation for the dinosaur. I'm on my feet just trying to think of an example of that. Okay, here's a silly example. Let's say all crocodilians can fly, all birds can fly, therefore the ancestor of all archosaurs could fly. Therefore, our baseline expectation should be that T.rex could fly as well. So we can reject that hypothesis for T.rex because it's just too damn big, right? But our baseline reference is what's shared between the croc and birds. And so that sets up our expectation. And in some cases, we can reject that expectation. Here's another example based a bit closer to reality. I think arguably birds are ancestrally social animals. Crocodilians are social animals as well. They would have inherited that from their common ancestor. Therefore, we should expect T.rex to have been social to some degree or another during its life. And that's a completely defensible hypothesis unless we discover something in the fossil record that contradicts it. And so as it And as it stands, I expect that T.rex and all dinosaurs, for that matter, were social. Why? Because we see that in modern crocs and birds, and we shouldn't expect any difference in their extinct relatives until we find clear evidence that contradicts it. That's the way it works. It's just a guide to thinking and to make, I guess, the search image clear for identifying contradictory evidence.
Is this the same sort of general approach that could be used for the purpose of reconstruction of a phenotype? Say, for example, if we find that in a Dromaeosaurida there is at least one example that shows feathery coverage, then it's only fair to reconstruct, until obviously further evidence either confirms it or contradicts it, that they would also have feathers.
Sure. The bottom line applies to everything that's inherited. As long as it's inherited, that's within reach of the EPB. That's behavior, that's muscles, that's vasculature, that's innervation, integument, and so on. Everything that's inherited. Because that's, the morphology is the product of natural selection. And natural selection works on morphology through the nucleic acids, through DNA. So if it's coded by DNA, then the EPB can help constrain that.
And one other thing I think maybe worth adding, I guess, is that the evidence that is provided, whether it supports the original hypothesis that was generated by the EPB, or whether it actually contradicts it, it helps us to better organize these little things on the shelves. Like, for example, when you said about the ancestral traits, how the common ancestor, for example, had feathers or similar, maybe filamentous structure that then gave birth to feathers. And then eventually we see that even as it progresses, that not necessarily it always progresses to the more complex. Sometimes it reverts back to the simpler sort of mode, so to speak. So we even have a paper done, I believe I think it's 2015, I can't remember the date of it, the publication. It's by, I think it's Paul Barrett and someone else, about the evolution of epidermal structures. The headline of the paper will be right here on the screen as I edit the video, obviously, but I don't have it at hand to bring it to the attention right now. But it has been discussed in that paper that in fact, they even actually cited Tyrannosaurids, that's even before Bell et al. Got published, that there is clear demonstration of reversal in their particular instance, that the evolution of integument does not always progress in a linear fashion from the simpler to the more complicated one. And then there are instances where it goes back to the simpler one again. So it kind of occurs in a slightly different matter rather than previously thought.
It's that, and that's standard for features among any metazoan, any animal, I guess any other organism, that you will see features evolve and then go away. They'll reverse back to the ancestral type, and that's just standard. We see that across the board. That's part of how natural selection works.
It's probably one of the things worth noting that when we look at this picture and when we look at the diagrams, we forget that the numbers that tell us the time gaps between them are absolutely huge and are like million times of what any of us have been around for put together. Like, we're talking huge differences of millions of years between the periods, and I think maybe it's worth noting that it's all has to be consistent with both the evidence, of course, from the period, and what, for the reconstruction purpose, maybe what makes sense perhaps most in that environment and in the period for the body plan to display.
That's an important point. I mean, if you read The Origin of Species, the great work of Charles Darwin, it was clear Darwin was very aware of geological time and the relatively slow rate of morphological change, extreme morphological change. And I think that's easy to forget. Like, I appreciate reading and rereading Darwin because geological time is always on his mind, and that is a very integral part of, for thinking about evolutionary change, whether it's integument or tooth form or something else. I think it is very important to be aware that the million-year time scale is a lot of time. The changes that occur on those time scales can be quite slow, but they do accumulate and they do produce great change.
Yes, it's quite easy to get confused and misled initially if you like all of a sudden forget what the numbers represent on the diagram and you think, oh, it's only like a literally 1 centimeter gap on this diagram. Yes. It must have been really quick. So yeah. One other thing I wanted to ask you is, this is basically two questions probably best combined so that we can wrap up this section and then move on to our bonus section and eventually reach our conclusion, as much as I hate it, but we do have to obviously get things done and organized and then get on with our business. So, see, there's this very interesting thing about what advice would you give to the viewers of this channel and just anybody basically who sees this video of how to research paleontology and how to conduct a debate on paleontological subjects. What sort of factors do we consider, and how do we apply scrutiny and make sure that obviously that we stay focused on applying scrutiny on both sides of the argument equally, rather than being, tempted by the bias to give in to what we might think we want to believe rather than what we should look at and conclude. Does my question make sense?
Yeah, it does. I mean, takes us right back to the initial scientific principles as laid out by Francis Bacon. And one of the most important things that he said was that we have to be able to recognize and reject our own biases. And we have to assess evidence dispassionately. But more specifically, I think for the audience, for the public audience, as well as the scientific one, is to pay very close attention to the scientific literature. And that's just what Dale Russell told me. And that's the best advice that can be offered. So even though it can be a struggle at first, reading the primary scientific literature, the articles that come out in PDF form that can be accessed, make the effort to read all the way through. I mean, that's what we do. And that's how our working baseline of knowledge builds up. I recommend not paying attention to secondary sources, but to go to this primary scientific literature and make your best effort to understand that. One big aspect of the training of a paleontologist is systematics, so cladistics, that is recovering evolutionary trees. And that's very specialized, and that's fairly advanced training that isn't always generally available to the public, but there are some publications and books out there that do describe cladistics, how cladistics works. And I think that is very important knowledge to have, to actually understand the literature, because literature is basically organized that way. And if you don't understand that, say, T.rex and T.rex are each other's closest relative to the exclusion of Zhu-Cheng Tyrannus, and those three are more closely related to each other than they are to, say, Daspletosaurus, then it's going to be a real sort of uphill battle to understand the nuances. So there is some investment in terms of learning, just how it's called tree thinking. And that investment does pay off. It does make things a lot clearer, I think, or would make things clearer to a public audience. But that's something that paleontologists already have. And so you will not find in the primary literature, explanations of how to read a cladogram. The assumption there is everyone already knows. But there are sources out there to help people along.
All right, that's a very good answer. And so for my viewers, once again, I'm going to quickly list a quick summary, so to say, prescription from Dr. Thomas Carr. So first one, read.
Yes.
Always read, specifically read the scientific literature and make sure that it's consistent and that you pay attention to the changes that have been made. I think that a lot of the pitfalls that people seem to find is a lot of times they cite papers, but they don't actually see the blind spot sometimes that papers do have flaws as well. Like a lot of times they refer to certain things that they are not actually representative when you start analyzing it, and you realize that what's wrong, but obviously it hasn't been yet published, so you can't really just go out on the street and make a claim, but you just know that it's wrong. So I think it's important to know these little pitfalls where they actually happen and be able to tell. Now, point number 2, whether you like it or not, science does not care.
Well, I like what you said about science doesn't care what you want. Nature will be what it is. And so, you just have to have the mental discipline of rejecting your own desires. That's what Francis Bacon wrote about. And as you have to recognize your own biases and reject them and just accept nature for what it truly is. And that does require some mental discipline and some mental vigilance. And it's hard. It's hard to, accept things that you don't like, but...
Now, how should we punish those who deny the natural awesomeness of dinosaurs, especially Tyrannosaurus? What's the punishment for that?
Oh, I just say, give them time, they'll come around.
So basically, long time of tease of having to obviously constantly remind yourself of dealing with the, what is necessary versus what I want, and then they come to the right conclusion. So the time in between is the punishment.
Yes, it's sort of a purgatory.
I don't know, maybe it's just like me kind of overthinking this a little bit, but I think that's a fair one.
Yeah, the bottom line, and I hope that the encouraging aspect is that it isn't hard to do dinosaurs accurately. And when I speak to artists who are starting out, what I recommend to them is that they pay strict attention to the form and proportions of the skull. That's usually the focal point. And that they take a stab at learning a bit of anatomy, say, get some scientific literature that describes, dissections of trocs in birds, maybe even dissect a chicken themselves to get an understanding of muscles, their arrangement, their form, that sort of thing. It really isn't hard to get dinosaurs right. And unfortunately, I see a lot, it's very, how can I say? There should be more accuracy out there than there is. Yeah, I think I think in terms of mass media, whether it's Hollywood or some other venue, that if you are making the claim that you are going to show people a dinosaur, that you make the effort to get it right. And I think that initially, just taking Jurassic Park as an example, I know that initially they did make that effort. And so, but then after the fact, areas that could be improved become obvious. You don't always get something 100% right the first effort. However, there's extreme cases where an extreme change is made. And so an example that would be the Dilophosaurus spitting venom and having a frill that extends around its neck. And that's fiction, and it does affect the public. And I can tell you from personal experience that when I let either members of the public know or inform students that Dilophosaurus did not spit venom and it didn't have the frill around the neck, the people have a tendency to be faithful to the first set of information they learn about something. And so if they don't know otherwise, they'll think that the Jurassic Park version was correct. And then I come along and contradict that. And so they experience a moment of doubt where they'll doubt what I'm saying. And then they have to make the effort to to reject what they thought they knew, and then accept the new version. And I think, I'd rather not people go through that moment, and and uh, and so why cause it in the first place? Actually, I don't know if there's images online, but at the Dinosaur Discovery Museum, we have a cast of the Rush Studios Dilophosaurus. Greg Paul was a consultant on that, so it's a lovely model. And I had it painted following Cuvier's dwarf caiman for the head. But since Dilophosaurus lived in a relatively arid environment, I had the body painted to match the freshwater crocodile of Australia. So it has sort of a dull yellow basement color for the body with sort of black saddles and bands as a pattern. And that there might be images of that online, I'm not sure. But that's something you might want to seek out to show your audience.
That would be amazing, yeah.
And that'll give you an idea of my approach to coloration. So
Did you paint the model yourself, you say, or?
No, the studio did
Okay.
in Chicago. I sort of gave them very detailed instructions in a diagram.
Right. So you gave them the manual and they did basically the rest of it.
Yeah, they did a great job too. It
Cool.
looks,
Awesome.
I think it looks really good. I think that the important takeaway here is that, in my view, there isn't much room for error. Like that there really isn't much latitude for screwing things up, if that makes sense. And so that's something that for people who take on projects like this, with the right guidance, they can really get it right, as close as possible. And there really isn't much wiggle room for, sort of eccentric decisions like the frill on the Dilophosaurus, for example. Yeah, and then that's an extreme example, and that applies to the more specific critiques I've made of the Jurassic Park Rex. That artists can have confidence that if they're faithful to the skeletons and anatomy as best as they know it, it's really hard to be that inaccurate. You just have to make the effort to be accurate.
Sure. And I wanted to also address this one last piece that has been... I believe you may have even seen this piece in the past, but just for the audience, if it's not a difficult thing to do. There's the image labeled Josh Rex. This is done by my friend, and he also happens to be a very good researcher in the field of paleontology, having done some good work. And also he is a Hollywood artist. And this black and white image of Tyrannosaurus, what do you think could be improved? Like, you can see that there are some things already incorporating, or at least making an attempt to incorporate the studies done in the Carr et al. 2017. And there are a few other bits and pieces. And of course, what are your thoughts on this illustration?
I think just the few pointers I'd give would be to define the outline of the skull, especially between the eye and the ear. I would beef up the depressor mandibulae. That's the muscle that extends behind the ear. It goes from the brain case to the back of the lower jaw. I think that could be a bit thicker. And the flat scales on the lower jaw, I think, can go all the way back to the jaw joint. And for the muscle, the adductor muscle that sort of is in the corner of the mouth, I would follow what we did for Horneri, because our version is based on what we actually see on the bones. So the front end of the adductor muscle is accurate in our drawing of Horneri. And so I would follow that. And that would change the position a bit. And so, Josh can take that and treat that for what it's worth.
Cool. I'm pretty sure he already appreciates the input because he was the one who, if you remember, I brought it up earlier, the diagram, the one on the red background. He is the author who put all of this stuff together and chased literally Dr. Phil Curry as well via emails, and he was on the field at the time as well. It took him time to obviously respond, and he was just sitting there scratching his fingers so am I gonna get it? Am I gonna get it? Did I get it right? Did I get it wrong? I need to know. And of course there's this thing that whenever we ask questions, we seem to always want to know everything right now. We don't seem to give enough time to respond. I'm personally admit to the guilt, well, not a pleasure, but to the guilt of having that habit quite a lot as well.
Yes.
And that's a good thing. So I'm pretty sure he will appreciate your notes and input. So to make it, obviously we've figured out what issues could be fixed. What do you think of the little bits that you can tick that were nicely done? Sort of say what you can recognize and can say that's consistent and what we can accept.
Yeah, well, obviously the flat scales with the ISOs, the lipless mouth, sort of the thickened armor-like skin around the eye, and on the top of the snout, those stand out to me as consistent with our hypothesis.
Good stuff. So we can see obviously the balance of points that need to be improved, and like every artist, Josh and myself and many other artists who are watching this video will probably know that artwork, it is what it is. You just keep practicing and you just keep getting it right. You just because you get it wrong the first time doesn't mean you should stop trying. So
that's right, absolutely.
And now to make another interesting point, I can't help but realizing it just hit me all of a sudden. It's just towards the end of the towards the wrap up is when you mentioned the pointer of the nostrils on how the t.rex has it and how Dr. Whitmer's reconstructions have shown. I think this is something we can agree and give compliments. If you go and open up the Saurian Rex 2 image, we can probably agree that this seems like a very nice and consistent representation of the nostrils. Would you agree, or do you think they're still quite a bit off? I think it seems to match your description.
Yeah, I think that is consistent with Larry's work. So it's that forward and down position. So that's, if I was consultant, I would suggest a nostril just like that.
The only thing we would obviously... so nostrils are definitely good at least. And I presume the nasal and the eyebrow structures, what do you reckon on that part? Do you reckon we could let that go, or we should again fry the steak, or should we say the turkey, given the amount of feathers that has on it? And Thanksgiving is approaching.
That's right. I think that's a bit much. I don't think you'd have as much definition on the top of the snout with those points. You only see something like that in animals like Ailuroramus. And I think the post-orbital horn is just a bit too enhanced. So I would tame those down a little bit based on what's seen on an actual skull.
So essentially all we have left to do is put the scales, remove these feathers, get the armored skin keratin coverage thingamajiggy on the face based on the paper, and trim down the horns, and what else? Get rid of the lips, obviously.
Yes.
So that doesn't sound like a lot to do, does it?
No, straightforward.
It's very straightforward. Right. Okay. Good stuff. So is there anything that you could share as well before we obviously wrap this interview up with my viewers and anybody else, anybody basically who watches this video? anything perhaps interesting, maybe a memory specific event that happened, something interesting during your fossil, expeditions and stuff like that? Maybe a story of some sort, just as a bonus if possible?
Yeah, well, last summer we were in Montana in our field area, and I had just found a microvertebrate site, and one of my crew radioed me and said that he had found a turtle in a cliffside, and I said, great, why don't you dig in and see how far it goes? And since it was a turtle fossil, I wasn't in much of a hurry to go see it. And I knew that this volunteer had already seen turtle fossils, so I assumed he was correct. And it wasn't until late the next day where I finally thought, well, I should go and look at this turtle. He's been pecking away at it for hours.
There's something suspicious about this turtle, given the amount of time people dedicate to talk about this turtle, isn't it?
Yes. And so he still thought it was a turtle, and I was expecting to see a turtle. And as soon as I got up there, I realized he had found a complete T.rex syringular. Oh. The syringular is the large plate-like bone that makes up the upper back quadrant of the lower jaw. And that immediately became a priority. So our priorities changed in a heartbeat. And we managed to collect it at around 2 a.m. the night before we left the field. So I had 4 hours sleep that night. But we have the strangler back in the lab, and my preparator, Dr. Megan Seitz, has started to work on it. And she has found, so she's working on the underside because we had to flip the jacket over.
Sure.
And she's uncovered part of a second bone.
Oh, so there was, obviously, it revealed that there was another bone as well in there, which wasn't obvious at first.
Yes, and and if it is truly a second bone, it's probably the prearticular, which looks like a sickle and extends along the inner lower edge of the inside of the back of the lower jaw. So we'll see. We may have two bones and not one. So fingers crossed.
Cool. Well, we'll be looking forward to finding out more, I guess, about this. It seems like there's a whole list already piling up for the interview part 2.
Yes, there is.
So, to wrap up what we have here, first of all, I am very 100% certain that my audience is 100% grateful for you for making this time and appearing on my channel. I am very grateful that you have made time and effort to appear on my channel. I hope it's definitely not gonna be, interesting choice of words. I hope it's not going to be the last time we have seen you on this channel. And me and my viewers and my friends as well would obviously wish you best of luck and have lots of fun in your upcoming projects in the Museum of the Rockies whenever you get there in January. So it will be exciting to see what sort of things happen there. And I wanted to give a quick summary of everything that we have covered, just maybe accompanied with short comments and to make sure that people by the end of this session will have something to take home. So first to take home is that all inaccurate dinosaurs make good steak material. Then second one is that read the scientific material and try to keep up to date with what it says, and always apply equal scrutiny to every single point of view. Don't just prioritize yours or the other over the next or the neighbors. Always apply equal criticism and scrutiny, even if you don't like it, because chances are once you accept the new hypothesis, you might open up the doors to learn something else that follows up. While if you keep obviously sticking to the old ideas, and should I say dated ideas, you are closing these doors and you're not letting yourself to learn more things. So would you agree with that, Dr. Carr?
I do.
Cool.
Yep.
And next point to take home is that Tyrannosaurus is awesome, and denial.
I agree with that too.
Yes, you agree to that too. Good. And I think many others are gonna spam this thumbs up button once they hear that, hopefully. And one other thing is that denying the natural awesomeness of Tyrannosaurids means you have to reevaluate your views on life, and the pain will obviously be the whole process by the time you realize that that's not the right thing to do, because dinosaurs are awesome. Right?
They are.
Yes,
yeah.
They are awesome.
They are so named for their awesomeness.
Exactly, yes. In fact, dinosaur should mean awesome creature, not terrible lizard, because dinosaurs are not terrible.
Agreed.
So then we have learned obviously a little more detail about the Splitosaurus horneri and its differences between the earlier species of Pterosus and how the anagenesis occurs, and that indeed it's not a very common thing to happen, and this is a very interesting point to study further and hopefully find for similar things that would have occurred in the past in this period, or maybe even Mesozoic as a whole, perhaps, because you never know when this might pop up in other instances.
Right.
And the next thing probably to take home is obviously that dinosaurs, specifically theropods, as has been recently popularized, did not have lips. And lips, as far as we know, they didn't happen in this in this category of animals. They are pretty much exclusive to mammals, am I correct? If we're talking about lips as scientific definition of the term of lips.
There's different versions of lips in amniotes, so mammalian style, which evolved for suckling. There are those sort of non-suckling lips that we see in lizards and snakes that almost certainly evolved independently of what we see in mammals, or that they would have had to have, but just similar structures just do not seem to be present, at least in Tyrannosaurus. At least that's the group of theropods I've looked at the most closely. And my expectation is that other theropods would be pretty much the same. But hopefully someone else will take up the task and make these comparisons. But that's my expectation.
Well, we can already make one comparison that you have cited, and I'm actually very grateful that you have not left that out, is the Neovenator saleri, I think. Is that the species and specimen we're discussing? Well, we weren't discussing, but we mentioned it throughout, in between the lines, which shows quite the same consistency with the Splitosaurus horneri.
Yes.
So this is already evidence that even creatures and theropods from different families and from earlier periods at that matter as well also had similar structures. So it is reasonable to start expanding that, at least at the very tiny bit of fraction, to that particular area. Maybe not, maybe to the point that when we find more, we can make a bigger sample of it. Hopefully one day, one day, yeah, one of these days. Maybe your kids can take up the mantle, and you never know, and continue the search if we don't get to see it. But I'm hoping that I would still live to see it, though.
Yes, same here.
Yes, let's hope for the best. Now, the next thing to take home is obviously, I think it's important, and one of the most important things to understand is that it's important to do our research correctly, and when conducting a debate on a subject of paleontology, to understand some of the ideas of what is a null hypothesis, what is perhaps even completely basic ideas such as burden of proof, which statements and claims require proof and which do not, and how to determine. We haven't really covered that in detail, but I guess it's fair to say that the burden of proof mostly lies on the positive claim to prove it, and if the person who is making a negative claim as a counter-argument has more strength if the positive claim does not provide the evidence.
Mm-hmm. Yes.
Am I making sense?
Yep, I agree.
So, in other words, we shouldn't be making any statements or assumptions. And but hey, I mean, one thing that I can benefit from this, and this is one of the things I hope that's not gonna stop, because it might potentially at least make me imagine that it would make me very rich, is that every time somebody makes a claim, I make 10 pence from the pound sterling, or make it 10, 20 cents or something, every time somebody says something, and I have to say citation, please. You know,
Yes.
like every time I have to say citation, please. If I were making a 10 pence on that, I would become millionaire by now.
You would. You definitely would.
Cool, awesome stuff. I hope you enjoyed the session. I
I did.
surely did.
Thank you very much for inviting me, and it's been a pleasure, and I look forward to doing this again.
Definitely, likewise, and I think my viewers can all say, yes, please bring him back again on the channel. We need more of him right here, right now. So, my voice is already dying, as you can probably tell by my intonation, because talking for, 4 hours, it's a bit difficult, and I talk a lot. So, that's the price you pay for running my channel. So, thank you for coming, Doctor. Once again, it was t.rex here, Dr. Thomas Carr here. Thanks for watching. If you want to see more of these videos, please hit this thumbs up, please subscribe. Also, don't forget to check out my Patreon. There's a campaign running with which I plan to start eventually making a documentary series. It's titled Race of Arms and Armor in Mesozoic, and if you want to see this happen and you want to know more about it, either pop a question down below in the comments or just check out the link in the description box below. Until then, it's been t.rex and Dr. Thomas Carr. Bye bye.
Bye. Thank you again.